this example right here wants to know how does the number of regions change when another point is added. So I'm going to just notate some things real quick. This is term 1, term 2, term 3, and term 4. Okay. How many regions do we have in the first one? We have 1. How many in the second one? 2, 4, 8. What is happening, or what's the pattern that you see? It's doubling each time. So if we add another dot and we have 5, how many would we have?
16.
We would have 16. Remember, this number is doubling, not the term number. What would our 6th one be? 32. 7th? The 7th would be 64. Yep. Questions about that example? Okay, so today is all about inductive reasoning. What that means is you're given a problem and you're trying to find a pattern. That's inductive reasoning. Okay? So inductive reasoning is when you're trying to find a pattern to help you figure out the rest of the sequence. Okay? We're going to talk about 2 different types of sequences. We're going to look at arithmetic, which means numbers, and geometric, which means pictures. Okay, so we're going to look at both of those. And then we're going to talk about some counterexamples. So go ahead and flip your notes over. We're going to talk about arithmetic sequences first, which is numbers. Okay, to find a pattern, we need to find the difference or what's happening between each term. Okay, so what's happening from 88 to 82?
Oh, it's subtracting by 6.
Subtracting 6. Okay, just because we found the first one, we cannot assume the rest of these are subtracting by 6. You have to prove it to be true for each one. So how do we get from 82 to 76?
6.
Subtract 6, 76 to 70.
Minus.
Subtract 6. Can I assume this one?
Yeah.
No.
Nope, don't assume. I'll tell you why later. And it is subtracting by 6. So what would our rule be? What was our pattern? Subtracting by 6 each time. What that's called, what the pattern, the rule is called, that's called the conjecture. I would write that in your notes. Conjecture is the pattern or the rule. Okay, so instead of saying pattern and rule, your textbook's going to ask you for what the conjecture is. So the conjecture of this sequence is what?
Minus 6.
Subtracting 6. Yep. If it wanted to find my next term, I would subtract 6 to get
58.
58. How would I find my next term?
Minus 6.
Subtract 6 to get 52. Okay? Let's look at another one that's not going to be so cut and dry. This sequence right here. We're going to find or do the same process. So how do I get from 3 to 5?
Plus 2.
Add 2. Can I assume all these are 2?
No.
No. 5 to 9?
4.
Add 4.
8.
9 to 15?
6.
6. 15 to 23? 8. What's happening in each one?
They're adding 2
It's
plus 2.
adding 2 each time. Okay, so what would I add to get my next term? 10 to get 33. What would I add for my next one? 12 to get 45. How would I write the conjecture? What's conjecture mean again? Pattern of the rule. So how would I explain the conjecture of the sequence?
Every number but 2.
It's not doubling. Each time they're adding 2 more. Okay? Good. 800 and 400. Minus 400. Anybody say anything else? Divide by 2. Okay, we're going to stick with both for now. What about 400 to 200? Divide by 2. Can I assume the next one is divide by 2?
No.
Nope. What's happening here? Dividing by 2 or subtracting 100. How would I describe my conjecture if I use that? I would just say divide by 2, right? How would I describe it with this one?
Minus is half.
What?
Minus is half.
Yep, minus its half or taking half of what it was from before. Which one's easier to say? Dividing by 2. Okay, so your conjecture would be divide by 2. I don't need you to write it out. If I see this, I know that's your conjecture. Okay, I don't need you to write divide by 2 separately. Okay. What would my next 2 terms be then?
0,
50. Oh, 50.
50 and 25. Yep. How many of you were stuck on B? Okay, let's talk about it. 18 to 24.
6.
What about 6? There we go. Plus 6. 24 to 32.
Plus 6.
It is 8. 32 to 128 divided by 3.
I have no clue.
What is this in the calculator when you typed it in?
42.6667.
Yeah, it's about 40, nope, not that. 42.6667. What's happening between 32 and that? What should it be? If you were following this pattern, right, if you added 10. So, is this sequence, does it work?
No.
No, it broke. So, no solution, or just say not a sequence.
Please do the 0 though.
Yep, this means no solution. Yep. So if the sequence doesn't work, that's okay. You just have to say doesn't work or no solution or whatever. Okay? So not all sequences will work. That's why you have to check to see if there's a pattern every time. Okay? Questions? Arithmetic sequences. Okay, again, what I mean by arithmetic sequences is it's just numbers. Now looking at this next example right here. This one isn't in your notes, so everyone look up here. This is a geometric sequence. So instead of, it's a different one. So instead of just looking at numbers, we're also looking at pictures. Okay? Talk with someone sitting next to you and see what pattern you see. How many of you went back to numbers and trying to figure out the arithmetic sequence?
I don't know.
What I mean by that, how many of you found the difference between 2 and 6?
Me.
A lot of us went back to that. Okay? What's the difference between 2 and 6? Adding 4, 6 to 12. Adding 6, 12 to 8. 12 to 20 is 8. What would I do next? Plus 10 to get
I told you.
30. Okay, so you can go back to the arithmetic way. What would my conjecture be? Adding 2 more each time. Okay. So that would be the arithmetic way. Let's talk about the geometric way. Okay, so not even paying attention to any of the numbers. All we're looking at is the picture. Okay. This right here is my original.
Yep.
My original and the next one is right here. What did they add to it? Don't use numbers. They added a column and a row. They added a column and a row. Here's my original and this one. What did they add? Column and a row. And then this is my original. What did they add? Column and a row. So if you use the geometric sequence, your conjecture would be what? Adding a column and a row. Does that make sense? Either or is correct. Okay, but I know some people are more visual and some people are more numbers. Okay, so either way works. Try the one in your notes, 2A and B. Let's look at the arithmetic way first. How many dots are in the first term? 1, second term, third term, fourth term, 19. Okay, is that my conjecture right there? No, I have to keep finding it. 1 to 5? Not just 4. Plus 4, 5 to 11? 11 to 19? What would my next one be? 10 to give me 29. How can I explain my conjecture? Adding 2 to its original each time. How can I explain it geometrically? Did anyone figure it out? What do you think?
I said add a row, add a column, and then add one to the top.
Bingo. Yep. So it's hard to see with this one. When you're looking for geometric sequences, it's hard to go from the first one. Pick the 2 in the middle to try and go from it. Okay. My original here, if I find box here, it's adding a row and a column, and then an extra dot at the top. Okay. So my conjecture for the geometric would be adding a row and a column and an extra dot at the top. Okay. Again, either or is fine, but some people are more visual, some people are more numbers. Okay. Questions about geometric sequences? Okay, there's one more I want to talk about, and that's if it's in a table. Okay, try and find a conjecture about this table. Okay, are we comparing these numbers, or are we comparing these numbers? The bottom ones, right? This is kind of saying the term. Okay, 10 to 13?
3.
Add 3. Can I assume all these are 3? No. 13 to 17? 17 to 22? Plus 5. What is the conjecture? Adding 1 each time. Okay. What am I adding this one? 6 to get 28. You got it. Okay. So we've been working on finding a conjecture. Again, what does conjecture mean? The pattern or the rule, right? Our example is opposite of what? Opposite of true, right? So if it gives you a statement and it wants you to find a counterexample. You have to find an example that makes that statement false. Okay? So now we're going to talk about counterexamples. Does anyone have any idea what so let's look at an example. We're going to jump right into it. Example 4. Okay? It tells you here what is a counterexample. So this is telling you that there is for sure a counterexample we can find. Okay, let's break this down. The sum, what does sum mean? Total, add, subtract, multiply, divide. Add, yep. The sum or addition of two composite numbers. Does anyone know what a composite number is? What? Nope. Does anyone know what a prime number is?
Yeah, it's more.
Prime number,
That can be divided.
right, a prime number divides itself by 1 in itself. What? Give me an example of a prime number. 3. Okay? 1 and 3 are the only numbers that divide 3. That's why it's a prime number. 1 in itself. A composite number, yeah.
Is one?
1 is a prime number. Composite number is opposite of a prime number. Okay, so someone give me an example of a composite number.
4.
4. Why is 4 a composite number? Because, yep, it goes into 2 goes into it, also 1 and 4. Does that make sense? So a composite number is opposite of a prime number. Capiche? Okay, so the sum of two composite numbers must be a composite number. How can we prove this to be false? How can we prove this to be false? The sum of two composite numbers must, we're going to keep this part. What do we need to change about the end?
Prime.
Right, we want it to be a prime number to prove it false. Okay, so the sum of two composite numbers must be a composite number, but we want to make that not true. So we want the sum of two composite numbers to equal a prime number to prove it to be false. Try and find it. I'll give you one and then I'll let you keep thinking. Do you agree 9 is a composite number?
Yes.
Do you agree 4 is a composite number?
Yeah.
9 plus 4? 13. Is 13 a prime or composite? Prime, so that's a counterexample to prove it to be false.
19 plus 4.
Then 9 and 4. Camden.
9 and 6.
9 plus 6, are those both composite numbers?
Yes.
What-
They equal 15.
Is 15
Oh, shoot, I added
Yeah.
There you go.
I got
Okay, so that one wouldn't work. That proves it to be true. Rosie.
21 plus 32 equals 53.
21 plus 32, those are both composite. And 53 is prime. Good. Spencer.
19 and 4.
19 plus 4 gives you
Wait.
Oh, wait.
23.
Never mind. I cancel that.
What's wrong with it?
19 is not over.
19's not a composite number. Matt.
25 and 4.
25 plus 4, both composite numbers equal
29.
29. Prime number? Good. Give me two more. Brian.
9 plus 8.
9 and 8. 17.
9 plus 10.
9 and 10.
No.
19. Perfect. One thing I want to talk about with all these counterexamples. Does everyone understand why this is a counterexample?
Yeah.
Because it proved our original statement to be false. Okay? Or wrong. I want you to see, is there a pattern between these?
They're all.
They're all
Odd number.
The answers are odd. Okay? Look on the left side.
Most of them have 9s.
Okay, other classes said that. That is not a pattern that we can see, but I understand where you get that from.
They all have
One odd, one
3.
even.
Bingo, who said that? Yep, what'd you say?
Has to be one odd, one even.
Right. Must be an odd number and an even number. Odd number and an even number. Because, why?
Plus equal odd.
Doesn't have to equal an odd, but most odd numbers are what? Prime. Are many even numbers not prime numbers? Right. A bunch of them are composite numbers, so we want to steer to the odd numbered answers. Okay? Awesome. Go do number 5, A and B. For every integer means a positive or negative number. N, the value of n squared is positive. So we want to see if this is true or false. Okay? Someone give me a random number.
45.
I'm using 2. If I plug in 2 to n squared, so that's 2 squared. What does 2 squared mean? 2 times 2, which is 4. Is it true? Yes, because it's positive. Let's try another one.
Negative 32.
I'm going to use -3. Squared. -3 squared.
9.
9. Is it true?
Yeah.
Yes. Let's try one more.
70.
No.
Negative 4.
5. 5 squared.
25.
25. Is it true?
Yes.
Yes. Do you agree that there is no counterexample to this?
Yes.
Why?
Because it's
We
always
just proved
positive.
it.
It's always going to be positive. I'm going to explain the B, your B, and then I'm going to let you try it, okay? What this is saying, a number is divisible by 4 if the last 2 digits are divisible. So if I pick 84, is 8 divisible by 4?
Yes.
Is 4 divisible by 4?
Yes.
Yes, so this is saying if I divide this by 4, it will be divisible, which this one is. Okay? Let me do another one. If I do 184, sure. Is 8 divisible by 4? Is 4 divisible by 4? Now it's asking, is it divisible by 4? Try it. 4. So I found 2 to be true. Do you think there's a counterexample to this? No, so it's true. Okay? Questions about counterexamples? Okay. Number 1, sorry. Yes, number 4. With these, what are we trying to do?
Find out how many reading it.
What?
Wait, on the.
On this one right here.
Uh,
So we need to go 4 to 11. How do I get there? Add 7. Can I assume all these are 7? No, 11 to 18. 7. 18 to 25. 7. What is our conjecture?
Plus
Adding 7. Yep. If I add 7 here, what's my next term? 32. Add 7 one more time. 39. Okay. Next one.
3 times. It just has 3 numbers in the pattern.
Oh, one more.
46.
Okay. Next one is the geometric sequences. Okay. Again, can you turn them into arithmetic sequences?
Yeah.
Yes. Okay. How many are in the first one? 2, 4, 6, 8. What's happening? Yep, and you could find that if you didn't know, you could do this like we were doing. And what happens between every single one? Add 2. What is your conjecture? Add 2. Yep, just understand that this is the conjecture when it's asking for it. What would my next one have? 10. Next one? 12. Okay. Number 6, counterexample. So it did not tell you if it was true or false. Okay, it told you had to figure it out. So for every integer, again, what's an integer? A negative or positive number n. The value of n squared plus 1 is odd. So if it ever gives you an equation like this, you're probably going to start plugging in numbers. Someone give me, Harrison, what'd you come up with?
7.
5.
If I plug in 5, what's 5 squared? 25 plus 1. Why is this a counterexample? Because it's even and it wanted odd. Okay? So then Harrison wouldn't have to do anything else. He'd be done. Did anybody else come up with another one? Brian. 3 squared plus 1. That gives you 9 plus 1, which is 10. Okay, and then Brian will be done because he found his counterexample. Harley.
7.
If I plug in 7, so I'd get 49 plus 1, which is 50. And then Harley would be done because he found one of his counterexamples. Okay? How many do you have to find if you can't find a counterexample? 3.
Trace.
Okay?